is the amount of matter a substance contains. An amount of matter in a substance, then it is measured in kilograms or kgs. Okay, so mass is measured in kilograms. The other word we may need to understand here is inertia. What is inertia? Okay, so inertia of a body is the tendency of not changing its state of rest or motion. If something is stationed, it means that thing is not moving, all right? It's at rest. Okay, so such tendency is called inertia. And inertia is a Latin word for laziness. A moving body keeps on moving with the same magnitude and with the same direction. Okay, such tendency is called inertia. When you see a body that is moving, but even as it is moving, it's moving with the same magnitude and with the same direction. So some of the examples of inertia. The first example is when a bus stops suddenly. Okay, the bus was moving, then there are brakes applied by the driver. You're going to find that the passengers will continue to move forward. Okay, there'll be that moving forward of the passengers because of the brakes, the immediate brakes that have been applied by the driver as the driver was moving. So another example we can give of inertia is, a fat person. A fat person can easily lose his balance if he tries to run in a zigzag manner. Okay, in a zigzag manner. The larger the mass, the larger the inertia. The smaller the mass, the smaller the what? The inertia. So this is something that we need to understand about inertia. A bus with a mass of 7,000 grams has a larger inertia than a car with a smaller mass. Okay, 1 ton, 2 ton, 3 ton, 4 ton. Okay, so we have a ton, we have grams, we have milligrams. So with ton, this is the symbol. Gram, this is the symbol. Milligram, this is the symbol. Now, when you get 10 power 3 kg, which is, how much is that? 10 times 10 times 10. 3 times, which is 1,000 grams, right? 1,000 kilograms makes 1 ton, all right? About 0.0001 kilograms makes 1 gram. What of this one? 10 to the power negative 6 kg. All right. Meaning this is about 0.000000001 kg or kilograms. Makes it milligram. Let's look at measuring mass. We use a beam balance to measure mass. Okay. So a beam balance is used to measure mass. So the most common balance is the triple beam balance. The triple beam balance is the most common balance used to measure mass. So what you need to understand here is, as you're measuring the mass, ensure that you zero the beam balance, and ensure that the pan and the beams are clean. Okay, this is just a caution. So we have traditional beam balances. Okay, we have types. Different types of beam balances. We have the triple beam balance. Okay, the triple beam balance is just one of the types of the beam balances that can be used to measure mass.
Let's look at the parts of a triple beam balance. It's called a triple beam balance because you have 1, 2, 3 beams, and on those beams sits 1, 2, 3 weights. This weight right here is for the 100-gram increments. This one's for 1 gram increments, or even tenths of a gram if you read these little lines here. And then this weight in the back is for 10-gram increments. This is the tray where you'll put your specimen, whatever you're measuring. This little guy right here is an adjustment knob. This is your scale or your zero. When you start out, you want to make sure that your balance is right at 0. And when things are too light, the balance will point up. When things are too heavy, the balance will point down. What else? Here's the base. That's about it. Parts of a triple beam balance. Again, tray, adjustment knob, riders, 1, 2, 3 beams, pointer, the zero or scale.
Mass of a liquid. Okay. So the mass of a liquid is equal to the mass of a container containing the liquid. You need to know the mass of the container. Then you subtract the mass of the container only from the measurements you found. Okay. So always when you're measuring the mass of liquid, you first need to know what is the quantity of mass. I mean, what is the mass of the container? When you know the mass of the container, then you're going to subtract the mass of the container from the amount, the mass that you found after measuring the mass of everything. And that is, for example,
the second way of using the triple beam balance is by finding mass by difference. Sometimes you need to measure the amount of, or the mass of a liquid or a fluid. You can't just simply pour this on the pan because it's all going to fly away or roll off. So what you have to do first is measure the mass of a container, such as a beaker, put it on the pan, move the largest rider first, make sure it's resting on a notch. Then keep going. It's resting on the notch at 200, but it dropped, so that's too much. Slide it back 1 notch. Now use the 10 grams, 1 at a time. Still hasn't dropped, so now make sure that now go to the next notch, and it drops, so that's too much. Send it back 1. Now you use the smallest rider until it zeroes out. And that's the mass of your beaker. Add up these numbers, and there you are. Then you have to pour in the liquid and start again, all the way back to 0. Move the 100-gram rider first, and again. It drops, so I move it back 1 notch. Now I use the 10 grams. 10, 20, 30, 50, 60, 70, it drops. I move it back to 60. Now I use the little one until it zeroes out. I add up the numbers and record my result for the mass of the beaker with the water, and now I subtract the mass of the beaker alone to get the mass of the water alone.
The mass of the air. So the mass of the air, when you want to find the mass of the air, you do the same. The mass of the container containing the air, all right, minus the mass of the container only. So after measuring, first you need to know the mass of the container before the air is put in there. After knowing that, you put the air, and then you measure. You measure for everything, that's the container plus the air. Now, for you to find the mass of the air, you will need to subtract the mass of the container from everything you've measured. That is, you've measured the mass of the container plus the air inside the container. So you subtract the mass of the container.
Gas. This is very similar to measuring the mass of a liquid. I have the gas in a container. I must first measure the mass of the container itself. Record that information on your paper. Then, measure the mass of the container with the gas. Record that information. Now, in order to find the mass of just the gas, I must subtract the container from the mass of the container from the mass of the container with the gas. That will give me the mass of just the gas.